Hello everyone, how are you all today? I hope all of you are doing well. So today we're diving into the sprint process, and I have broken this sprint into three user stories. Think of these user stories as mini tasks within our project. Each user story is assigned to a developer. So here's how it's structured. User story 1 is where the developer is working on the sign-up form. Here it includes the fields and the buttons. For user story 2, the developer 2 is focusing on working with the side panel. And for user story 3, the developer 3 is handling the top menu. Okay, here there are categories like laptops, desktop, etc. And of course, we also have testers assigned to each user story. Each testers will be responsible for validating the functionality once the development is done. Now let's talk about how the developers are managing their work. They're using the website called GitHub. GitHub is like a hub for developer. It is a place where they can collaborate, share, and store their code securely. Each developer has their own personal folder in GitHub. We call it the branch. For example, in branch 1, the developer 1 works with his sign up form. And then in branch 2, the developer 2 is working with his side panel. And in branch 3, the developer 3 is working with the top menu of the code. These branches act as a sandboxes. So all of these are as a sandbox where they can work independently without interfering with the main project. Now testing the code with Angular. Okay. Once the developer have written their code, they need to test it. Now, how do they do that? They use a framework called Angular. So they use Angular. Angular. Angular is like a builder for application. Think of it is as a tool that helps developers integrate their code and see how it works in a dummy interface. So here's what happens. Once the developer places their code in Angular, place their code. Then the Angular processes the code and create a layout. For example, the developer once sees the preview of the sign-up form with the fields and buttons. Let me show you. So here the developer sees a preview of the sign up form and with fields and buttons. Then the developer too, so here is the field and button. Here is the field and button. Then the developer too sees the side panel with the login details. Here is a mistake. It says developer 3. Don't worry. And for the third one, here is the top menu. This is the top menu with the categories. Angular allows them to visually verify the code, ensuring the layout and the functionality are correct. Now, to submit a pull request, once the developers are satisfied with their work, they submit a pull request. So, what's a pull request? A pull request is a simple way for a developer to say, hey, I have completed my part. Can someone review and merge it with the main project? They send this request to the technical lead. So, they send this request to the technical lead. The technical lead reviews the code. He checks for is there any bug in the code? Is the code clean? Does it follow the coding standard? Will it work well with the other developers' code, etc. After the code looks good, he merges it with the master branch. This merging process integrates all parts, the sign-up form, the side panel, and top menu, into a cohesive project. Now, after the merge, something crucial happens. A repository link is generated. This link is like the key to the latest version of the entire project. It's created in the master branch, which is now up to date with all the developers' contributions. Then comes the DevOps teams, the heroes of deployment. Their role is to ensure the project transitions smoothly from development to testing and eventually to the users. So after that comes DevOps team. They use a tool called Jenkins, which automates the development process. So they use Jenkins. So how Jenkins works? First, the DevOps team take the repository link and puts into the Jenkins. Jenkins processes the code and deploys it into the test environment. After deployment, Jenkins generates a build trigger, essentially a button that finalizes the process and make the application ready for use. Okay, so here the DevOps puts the code into Jenkins. Then it processes the code. After that, it creates a build trigger. Um, it creates a build trigger. At this stage, you can see the graphical user interface or GUI. Everything the developers worked on is now live, like the sign up form, the side panel, the top menu, etc. So, with the application deployed, it's time for the test lead and testers to step in. Here's how they proceed. The test lead uploads the repository link into the dev environment, like Confluence. Then the testers are notified and provided with the link to start the testing. Each tester focuses on their assigned part. Like the tester one validates the sign up form, tester two checks the side panel, and tester three tests the top menu. Okay. They conduct rigorous testing to ensure everything functions smoothly and report any bugs they find. Now let's talk about the sprint timeline. A sprint timeline lasts 4 days. So sprint timeline, sorry, 14 days. Okay. So it lasts 14 days. In the first 7 days, it is the development phase. And the last 7 days is the testing phase. In the development phase, the developers write and test their code in Angular. And in the testing phase, the testers validate the application using the deployment link. This division ensures that we meet our deadlines without compromising the quality. So in conclusion, the developers write code in branches on GitHub and test it using Angular. Then they submit a pull request to the technical lead who merges it into the master branch. The DevOps team uses Jenkins to deploy the application and generate graphics user interface. The tester validate the application in the deployment environment during the testing phase. This streamlined process ensures that every piece of the project comes together seamlessly. If you have any questions till now, you are feel free to ask. Now let's talk about uh, backlog grooming, also known as the refinement session, front-end testing, and smoke testing. So you can ask what happens during backlog grooming or refinement sessions, how front-end testing validates the connection between the user interface, API, and database, the purpose and methodology of smoke testing. Let's begin by the thing called backlog grooming. Backlog grooming. So what is the backlog grooming? The backlog grooming or refinement session is a structured meeting where the development team organizes and updates the product backlog to prepare for upcoming sprints. These sessions ensure that the backlog is clear, prioritized, and actionable. So why is it important? The backlog grooming ensures clarity. The developers or testers gain a shared understanding of what's happening. Then it prepares Story of sprint plan. Tasks are refined so that they are ready to be worked on. Also, it minimizes the confusion during in sprint execution. So the backlog grooming reviews each user story that has a clear description, acceptance criteria, and enough detail for implementation. Then it reorganizes the backlog items based on their importance and business needs. It also assigns effort points to tasks to complete the tasks and reduce their complexity or workload. It also identifies who will work on specific stories. For example, imagine your team is tasked with building a shopping cart feature for an e-commerce website. So during the backlog grooming, the developers clarify user story like add items or remove items from the cart. Testers suggest edge cases to consider, like handling invalid coupon codes. Story points are assigned, such as adding items might take 5 points, while implementing discounts might take 8. Updates are logged in Jira for tracking. So some organizations implement updates right after the refinement session. Others wait until the sprint planning meeting. So backlog grooming prepares the team for smooth execution of tasks in sprints by organizing and detailing the product backlog. Then comes the front-end testing. Front-end testing. The front-end testing is a process that ensures the application's user interface connects seamlessly with its backend system. There are some key components like UI, API, database. In UI, the visible part of the application is where the user usually interacts. The API acts as the middle layer, facilitating communication between the front end and the database. So they go through the API. The database is the storage system where data is retrieved and stored. During front-end testing, the main objective is to ensure the data entered on the UI is sent correctly to the database via the API. It also checks responses from the database are accurately displayed on the UI. For example, imagine you are testing the login page of an application. Okay, so the login page. You have like email, password, etc. So you input valid credentials to check if the API retrieves the correct user profile from the database. You input invalid credentials to verify if proper error messages are displayed. There are some tools used for front-end testing. Some of they are Jira, Excel, Confluence, API testing, tools like Postman. So, Jira is used for managing test cases and defects. The Excel is used for creating manual test cases. The documentation is worked on by the Confluence. And the post API testing tools like Postman are used for validating API responses. Okay, now in Agile methodology, testing happens iteratively during development. Agile tools like Jira and Confluence are used for planning, tracking, and documentation. Front-end testing ensures that the UI, API, and database works in harmony to deliver a smooth user experience. Now let's talk about smoke testing. What is a smoke testing? Hmm, let me show. So the smoke testing is a basic shallow level test performed to validate the essential and critical functionalities of an application. Think of it as checking the vital signs of your software before diving into detailed testing. It is performed to ensure the critical feature of functioning as expected. And it is also used to verify the software is stable enough for more in-depth testing. Uh, the characteristics of smoke testings are it's broad but shallow. It focuses on major functionalities rather than in-depth testing. And it takes usually minimal time to execute. It can be manual or automated. For example, suppose you have developed a login page for a website. Smoke testing for this page would involve checking whether the user is able to enter valid credential or log in successfully. So you check if the user can input valid credential successfully. Then you verify that the system shows error messages for invalid inputs. You click on essential buttons like submit or cancel to ensure that they are working properly. In essence, you test only the major features to confirm the application is ready for further detailed testing. So, the difference between smoke testing and other testings are smoke testing focuses on critical functionalities. The regression testing ensures recent changes haven't affected existing functionality. And the system testing checks the complete application. For smoke testing, you don't need any specialized tools. It can be done manually. For automated smoke test framework like Selenium are often used. So smoke testing is a vital step that verifies the basic functionalities of the application before proceeding into the deeper testing. Now let's move a step further and dive into sanity testing. Okay. Now let's go to sanity testing. Sanity testing is a subset of regression testing. It's performed to verify the specific functionalities of a system after bug fixes or enhancement. The goal is to ensure that the recent changes haven't broken anything in the related area of software. So it is used for specific functions. So when do we perform sanity testing? After bug fixes to check if the issue have been resolved. So it is used after bug fixes. Then it is used after adding new features. After new features or modules that are added to validate their implementation. Also to confirm that the mixed and newly added feature works properly without disrupting related functionalities. For example, imagine we are testing a registration page. So here is a registration page. Now, during smoke testing, you find that the continue button is not clickable. You report this to the developer who fixes the issue and sends to the updated version. Now your task is to verify two things. Is the continue button is working after the bug fix, and has this fix affected any other features such as buttons or field in the registration field? This focus testing of the continue button and its surrounding functionalities is called sanity testing. So, for instance, the developer has fixed the continue button. So it checks validates if the button is working properly. Then it sees like the anything called suppose it has uh, it suppose the first name, the last name, the email, the telephone, all of them works perfectly or not after the bug fixes. Excuse me. So sanity testing focuses only on the specific areas that were affected or changed. It doesn't involve in retesting the entire system as regression testing does. So what is the difference between sanity testing and smoke testing? Sanity versus smoke. So for purpose, smoke testing broad check of basic functionalities, whereas sanity testing focus on specific areas. And when are they performed? Smoke testing is performed after a new build is created, and sanity testing is performed after bug fixes or minor updates. The scope of smoke testing is very shallow and they are very quick. The sanity testing is in-depth testing of specific functionalities, so it may take a little time. The smoke testing ensures software is stable for further testing, and the sanity testing validates fixes and enhancement in details. So you can think of smoke testing as checking whether a car engine starts and the tires are inflated. And the sanity testing is like taking the car for a short test drive after repairing the brakes to ensure they work without testing every feature of the car. Now, what is the relation between sanity testing and regression testing? Sanity testing is a subset of regression, but it's more focused. So to understand the difference, you can say sanity testing verifies bug fixes or specific enhancements, whereas the regression testing ensures the entire application still works correctly after changes. For example, when you test the continue button and related fields, you are performing the sanity testing. Okay. Now, if you test the entire application, every page, every feature, and every workflow, it to ensure no bugs were introduced elsewhere, you are performing the regression testing. So here is an image to make you understand correctly. You can read it. Okay. Now, why is sanity testing important? So, the importance are it is efficient, it is quick validation, so sanity testing saves time by focusing only on the affected areas. And it allows developers to identify and resolve issues rapidly. It also confirms that changes or fixes haven't negatively impacted related functionalities. So you can say, can sanity testing be automated? The answer is yes, but it is often done manually because it involves verifying specific changes. So what happens if the bug persists? If the issue remains unresolved during sanity testing, it is reported back to the developer with detailed feedback. So you can ask if they should be documented. While it doesn't always require formal documentation, it's a good practice to log the tests performed and their results, especially in environments with strict quality assurance processes. Sanity testing is a targeted and efficient approach to validate software changes and bridging the gap between smoke testing and comprehensive scope of regression testing. So let me know if you have any question with this, or else we can dive into more deep. Excuse me. Now, uh, now let's take a dive into regression testing. When developers fix an issue or add a new feature, like when the continue button functionality was corrected, you perform regression testing to ensure that the fix doesn't break other features and the rest of the system remains stable. So let's imagine this. The sale page continue button is fixed and now works correctly. But you also test other related features like adding an item to the cart, applying a discount, other options. This process ensures the new changes haven't disrupted any existing functionality. Regression testing is document heavy. You write detailed test case, keep track of changes, and document any issues. So what happens when the regression testing fails? If a bug persists during regression testing or a new issue arises, you send the defect back to the developers for fixing. This process repeats until you achieve a stable version that meets all requirements. Testing, fixing, and retesting are iterative and ongoing. The goal is to ensure a stable and reliable, reliable product. Now, integration testing. Integration testing ensures that individual components work together seamlessly. Imagine a website with multiple interconnected sections like desktop, PC, Mac. When you click on desktop, you are taken to the desktop session. From there, you click on PC, it navigates you to the PC section. Finally, you click on Mac and it opens the Mac section. Here you are testing whether the links between these pages work correctly. Each click must lead to the intended page. This ensures the system is properly integrated. If you click PC and it redirects to a wrong or blank page, this is a failure. This type of testing checks the flow between different modules. Now let's talk about graphics user interface testing. Here you evaluate the visual elements of a software application that includes the layout, the design, the functionalities from the user's perspective. So you can see that there are some images of graphics user interface. It's testing the software's graphical interface to ensure that they meet the minimum requirement, they function correctly, they provide a good user experience. So the graphics user interface includes uh, there's a little problem. Okay, now the graphics user interface includes layout, elements, and responsiveness. For layout and designs, you can check out the colors and fonts are correct. Is everything aligned properly? Are there any spelling errors? Okay. Now, for interactive elements, you can say, do the drop-down checkboxes and search bar work? Are scroll bars functional? And in responsiveness, you can check, does the layout adjust properly across devices like PCs, tablets, or phones? If it works on Android, does it work on iPhone or Linux, iOS or Linux? For example, when you open Amazon.com, the graphics user interface ensures the search bar is functional. The drop-down menus like departments expand and display correctly. The currency toggle switches between options seamlessly. If if even a single drop-down doesn't work or there's a typo in the button text, it can harm the platform's reputation. Okay, now there are several challenges in graphics user interface, like pop-ups or ads, compatibility, updates. Some websites like free movie or learning platforms have intrusive ads to disrupt the user experience. For example, ads pop up every few seconds during a movie. Then this few frequent interruption make the site less user-friendly. This is a graphical user interface issue. Then for device compatibility, imagine accessing a website from a PC. Here, everything displays correctly. A mobile phone, the layout is broken. A Linux operating system, parts of the screen are missing. So, this test ensures the layout and functionality remain consistent across all the devices. And for software updates, when an operating system or browser updates, compatibility issues can arise. For example, a form that worked perfectly on Android now doesn't display properly on the latest iOS update. So for graphics user interface testing, you don't write separate test cases. Instead, you follow the requirement document. For example, if the requirement says that layout should remain consistent across the device and operating system, you test for it. So, who creates the graphics user interface? The developer is responsible for creating the GUI. They write backend code to connect element and use tools like Angular and Jenkins to build the dummy interface. So now let's talk about functional testing. Functional testing validates the application behaves as expected. It includes various subtests such as positive testing, negative testing, calculation testing, smoke testing. So, there are user acceptance testing and production testing. They will be taught into the later stage. Okay. The positive testing means the inputs are validated as checks the system response. The negative testing enters invalid inputs to verify the system handles error gracefully. For the calculation testing, it ensures mathematical operations are accurate. The smoke testing is used for a quick check to see if any major features work before deeper testing. Now, do you need to memorize all the testing types? No, but you must understand the concepts. While no one will directly ask, did you perform positive testing or negative testing? Your understanding will guide how you conduct this test systematically. If a test lead asks, have you finished functional testing? You should know it involves all these components. Now, in real life project, you must combine your understanding of GUI testing, integration testing, and functional testing. So, GUI plus integration plus functional. Your ability to navigate through requirements and execute tests systematically is what matters more. So you can have some questions to reflect on, like, are you clear on the difference between the regression and sanity testing? Do you understand the goals of GUI testing and its challenges? Can you identify when integration testing is necessary? So let's talk about positive testing and negative testing. Let's begin by understanding the positive testing. Positive testing is when you check if the system functions as expected when valid inputs are provided. Essentially, you are testing if the application accepts the correct data and operates normally. For instance, if the requirement of first name says it must be 1 to 32 characters. If a tester enters a name like John, it's within the valid range. The system should accept this input without any errors. This is considered positive testing. The system behaves normally with valid inputs. Now, for negative testing, which is designed to verify how well the system handles invalid inputs, this helps to ensure the system doesn't accept any random data and it is appropriately rejected. So here is an image that shows the difference. Let's consider the same scenarios from above. First, the first name must be 1 to 32 characters. If the tester tries an input name like John Doe, that is way too long. It is a 33 character and it exceeds the allowed length. According to the requirement, the system should reject the input and display an error message. Something like first name must be 1 and 1 to 32 characters. This is an example of negative testing. Another common case is with passwords. If a password is supposed to be between 4 to 10 characters long and a tester's include 22 character long password, the system should reject it with an error message such as password must be between 4 to 20 characters. Again, this behavior falls under negative testing because we are testing a system response to invalid inputs. Now for the difference between positive and negative testing. The positive testing system works as expected when you provide valid inputs. And the negative testing works if you provide invalid inputs and it displays error. Now moving on to the error handling. Error handling refers to the way the application responds when something goes wrong, like when the user enters invalid data. The system should not just crash or fail silently, but instead it should show a helpful message to the user, explaining what went wrong and how to fix it. For example, if a user tries to enter a first name longer than the allowed character limit, the system should show an error message. In testing, error handling means identify where errors might occur to the application and ensuring that the system responds with appropriate messages and suggestions or guidance for the tester. A tester will often have to make sure that the application is robust enough to handle errors, meaning it should be able to recover gracefully without any crashing or causing issues. When conducting error handling, testers often maintain documents that list all the part of the application where the errors are expected to appear. This is a useful technique because after a testing product for months, the testers may need to revisit these error-prone parts again just before the product is released. By maintaining a checklist, the testers can quickly verify that the system is still generating those correct error messages, warnings, and suggestions. This approach helps to ensure that the product remains functional and user-friendly. Even when things go wrong, it is a critical part of the final release testing, making sure that the application gracefully handles any unexpected user behavior. So, for summary, the positive testing includes the valid inputs and verifies expected behavior. The negative testing shows the invalid inputs and checks if the system properly rejects them and provides a correct error message. And the error handling is the way those error messages are handled with guidance or messages to the user. Now let's move on to calculation testing. L- Suppose we are shopping online. You see that there is a cart icon uh, on top of your screen. Now, let's say you are browsing for an item and decide to add the item in the cart. After you click this, you see the cart update. It should say one item in the cart. It is a expected behavior. Now let's another one item in the cart. When you do that, it should update and show two items in the cart. That's exactly how it's supposed to happen. So what we have done is perform calculation testing. This type of testing ensures that when we add items to our cart, the system calculates the total number of items correctly. For example, if I add 12 items to my cart, but the system only shows 5, that's a problem. The system should always match the items in the cart. Okay? But if the calculation is wrong, the business could lose money. For instance, if the system shows fewer items than actually added, customers may be charged incorrectly, leading to a loss. This is why calculation testing is critical for e-commerce platforms. It ensures that the number of items, prices, and subtotals are calculated accurately. So it is for number of items, prices, totals. Now you might wonder, why do we need to test this? What's the purpose? The goal is to ensure that the user experience meet their expectations. Customer expect the card to reflect exactly what they added. Any discrepancy, no matter how small, can cause frustrations and lead to loss of sales. Let's also consider the priority and severity of a bug in a calculation testing. If there is a calculation error, how would you rate its impact? The priority is high because the bug directly affects business operations. The severity is also high because of customer are incorrectly charged or items are missing from the cart. The business could lose customers or could lose severely damage its reputation. So high severity, high priority. Now, what's the difference between calculation and manipulation testing? In manipulation testing, we check how the data we input into the system is manipulated or processed. When you add an item to the cart, sometimes the system might tell you that you have 5 items left, but you have already added 12. This is an example of manipulation testing. So, calculation and manipulation testing involves making sure that the system correctly calculates and reflects accurate numbers. For example, if you see that only 5 items are left in stock after you have added 12, the system should update the inventory count correctly. Now let's shift gears and talk about link existence testing. Have you ever noticed when you click on links like the gift cards section of an online store? These links are supposed to take you to the right page. In link existence testing, we check if the links lead to the correct destination or not. For instance, if you click on gift card link, it should take you to the gift card page. If it doesn't, then the link isn't functioning as it should. If it takes you to the wrong page, like a contact form, then we have a problem. This type of testing ensures that all links on the page are properly connected. And they also help to navigate the user to the intended location. Let's talk about cookies and session. You know how when you log into a website, sometimes it asks if you accept cookies. These aren't the cookies you eat, okay? Cookies are small pieces of data that the website stores on your browser. They remember things like your login details, preferences, and shopping cart items. Cookies testing ensures that these small pieces of data stored securely and correctly. For example, after logging in, and the system should remember who you are and what are your preferences. So when you return to the site, everything is personalized for you. Now let's discuss session testing. Have you ever stayed logged into a website for a long time and noticed that the system logs you out automatically? That's because of session expiration. In session testing, we check that the system keeps you login for the correct amount of time, then logs you out after a certain period of inactivity. For instance, if you log into an Amazon account and it keeps you logged in for 3 months, that's a session behavior. However, after 3 months and a few days, the system will log you out for security reasons. That's session expiration. Session testing ensures the website maintains the user state accurately and securely. Now, this for security and sessions. In sensitive applications like online banking, session testing becomes even more critical. If someone tries to log into a bank account from a device after a long time, the system will ask for authentication to verify the user. If the session has expired, the system should log the user out and require re-authentication. This is essential for protecting sensitive information and ensuring the safety of user data. Now, we are going to talk about two important meetings in the Scrum framework. The sprint review meeting and sprint retrospective meeting. The, these meetings are vital for ensuring that the work is progressing as expected and the team is continuously improving. Let's start with the sprint review meeting. Now I'm going to ask you now, what do you understand by the term sprint review meeting? In sprint one, after the team is given a task or a component to work on, the sprint review happens at the end of the sprint. Once the period for the task or component has completed, the team reviews whether the task has been completed and meets the requirement. So, sprint review meeting is held after the completion of a sprint, where the team presents the work that was completed during the sprint. It's not just show and tell, but a demonstration to the stakeholders such as product owner, business analyst, business people, and product managers to show them the progress made on the project. So, in a typical sprint review, after the sprint has finished, the team shows the completed features or components to the stakeholders. This meeting happens after every sprint to give the stakeholders a chance to review the work and provide feedback. So, why is this meeting held in the development environment? The reason this happens in the development environment is that Even though the product is still in development phase, the goal is to demonstrate that the progress has been made. The stakeholders will review the functionalities and give feedback that can guide further development. Now, the purpose of the sprint review meeting is to demonstrate the complete work to the stakeholders, gather feedback on what has been done, discuss possible future adaptations to the product. It's important to note that the business stakeholders are present in this meeting to assess the product, provide feedback, and evaluate whether the work is aligned with the business goals. This is the part where the product team and the stakeholders discuss the product and ensure that it is heading to the right direction. As we move forward with Scrum, the sprint review meeting will be held after every sprint, where you will showcase the completed work and get feedback. And now for the sprint retrospective meeting. Following the sprint review, there is another important meeting, the sprint retrospective meeting. This meeting usually happens immediately after sprint review. What do you think this purpose of this meeting is? Is it about discussing how the product progressing? So the retrospective meeting is focused on the team's process and performance. Unlike the sprint preview where stakeholders are present, here it is mostly an internal meeting with the Scrum team. The meeting is used to reflect the sprint and assess what went well and what could be improved. The team will look back into the sprint and discuss what went well during the sprint, what didn't go well, what should we do differently next time. It's a meeting of self-improvement. So it's a meeting of self-improvement. It is aimed at helping the team continuously improve and adapt challenges. Business stakeholders are not part of the meeting because it's focused on internal team dynamics and improvements. The goal is not to review the product but to review the process. So, how is it different from sprint review? In sprint review, stakeholders provide feedback to the product, while the retrospective, the team discusses how they can improve the product processes, communication, and technical skill. For example, let's say a developer has communication issues or struggling with collaboration. That could be noted in the retrospective as an opportunity for improvement, where the team agrees on ways to improve communication or provide additional support. So now that we've covered the meeting, let's quickly go over some testing tab. You have heard like smoke testing, sanity testing, positive negative testing. So in brief, the smoke testing is the initial round of testing conducted to ensure the basic functionalities of an application are working. For example, check if the home display is working without errors. Confirm that the search bar is working. Then test if the add to cart is working. In smoke testing, you are not going too deep into the system. You're just ensuring that most of the critical part are functional. It's like checking whether application is stable enough to proceed with more detailed testing. In sanity testing, it is more of a targeted type of testing. It is usually focused on the new features or bug fixes. So this test ensures that the functionality works as expected after the changes has been made, without impacting other areas of the system. For example, if a bug was fixed in the add to cart functionality, sanity testing will ensure that this fix hasn't broken any other parts of the application. Now, for positive negative testing, the positive testing checks if the system behaves as expected under normal conditions where the input is valid, and the negative testing is uh, handles invalid inputs or unexpected scenarios. Excuse me. Now, integration testing and system testing. After this test, we move to system integration testing or SIT. SIT. Here, the individual components or features are integrated together, and the tester verifies if everything is working in sync. For example, if you have a registration page and a login page, initially this might be separate components. However, once they are integrated, the testers will ensure that the clicking on the login button takes you to the correct page. The user can navigate seamlessly between features, such as moving from registrations to login or from product page to the on the card. Excuse me. So the example can be let's consider that in the initial stages of the development, the login and the registration page were separate, and clicking on the login button didn't lead you to the login functionality. However, the system integration testing, these pages are now integrated, and you will be able to navigate between them seamlessly using one unified link. This is when the developer integrates all the pages, and you will test whether the product is functioning as a complete system. So to summarize, smoke testing checks the basic functionality, sanity testing verifies new changes or fixes work without breaking other functionality. Integration testing ensures that the components of page, once integrated, works as expected. So on final thoughts of testing, testing plays a crucial role in ensuring that the final product meets quality standards. It is done in different stages, starting from starting from smoke testing to ensure stability, followed by sanity testing for verifying changes, and then more detailed testing like system integration testing into sorry, end-to-end testing. Testing also ensures that the business goals and customer expectations are met. As part of the Scrum process, testing is continuous, and feedback from the sprint review and retrospective meetings is incorporated to improve the product and processes for future sprint. So you are now equipped with the basics of sprint review, sprint retrospective, and different types of testing involved in the process. So make sure to study these concepts and apply them in the real world scenario. Over time, this process will become smoother and will get better at identifying areas of improvement. I hope this makes the concepts clear for you. If you have any questions, feel free to ask. We will review this in future sessions as well. So till then, take care of yourself and I'll see you in the next class. Okay?